Section 6.7, permutations and combinations. We're going to count permutations and we're going to count combinations. So permutations we're going to talk about first, and before then we're going to talk about this right here, which looks like an exclamation point. It's actually called a factorial. And for factorials, we write like n factorial. If we wanted to do this or evaluate it, it would be n times n minus 1 times n minus 2, all the way down till we got to 1. So for example, if I have 0 factorial is always going to be equal to 1. If I have 1 factorial, that is also equal to 1. 2 factorial would be equal to 2 times 1, which is 2. If I have 3 factorial would then be 3 times 2 times 1, which is 6. 4 factorial, then we would do 4 times 3 times 2 times 1, which is 24. And of course we can keep on going. So a way that you can easily do this in your calculator is, let's say we wanted to do 5 factorial. So 5 you type in first, then go to math. Notice that the last column right here says PRB, it stands for probability. And if you look at number 4, that gives us our factorial, and enter. So 5 factorial is going to be equal to 120, and I could keep on going. So examples of this, in how many different ways can 10 dogs line up to be groomed? Well, if you have 10 dogs and you want to line them up, well, the first spot that you have, you're going to have 10 different spots, right? So 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So if you have 10 dogs, then 10 goes in the first spot. Well, if you put 1 dog in that first spot, then you only have 9 left. So 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So if we multiply all these together, this is going to give us our answer, which is really equal to 10 factorial. So in how many different ways can 10 dogs be lined up? So you can go to your calculator, 10, math, and probability number 4, and you get this number right here. So we're going to write that down. So 3,628,800 ways the dogs can be lined up. So number 2 says, in how many ways can you arrange 6 trophies on a shelf? So it's the same idea. So if we want to arrange 6 trophies on the shelf, we would do 6 factorial. So 6 factorial would be 6 times 5 times 4 times 3 times 2 times 1. So 6 factorial then gives me 720. So that's for factorials. Factorials are helpful because we can talk about them when we're doing permutations. A permutation is an ordered arrangement of a set of objects. Use multiplication counting principle or factorial principle to help you do this. So in a permutation, the key thing to remember is that order matters when we're talking about permutation. So that's going to come in hand when we talk about combinations. Now, the number of permutations, the way that you calculate it, is we're going to use our calculator for this, but I'm just going to show you the formula. So n, and then we have PR in the calculator, which is really equal to the formula n factorial over n minus r factorial. So that's the formula that we would use, but we're not really going to use that formula since we can do this into our calculator. N stands for the total number of objects that you have, and r stands for how many that you're taking at a time. So n objects taken r at a time, so that would be this number right there that we're going to use. Or you can say, out of n items, we're going to choose or select r of them. So looking at number 1, it says, 7 yachts enter a race. First, second, and third places will be given to the first 3 fastest yachts. How many arrangements of the first, second, and third places are possible with 7 total yachts? So, well, let's think about this for a minute. We have 3 different spots that we're looking for and 7 boats. So if you have 7 different ways for the first one times 6 different ways for the second space times 5, it gives us a total of 210 possible ways for first, second, and third place. So what we're really doing is we have n, which is the total number of boats, which is equal to, in this case, 7. And r is how many spots that we have. So we have 3 spots. So if we use our formula, we're really doing 3, and then p stands for probability. Or sorry, I wrote 7. And p stands for probability of 3. So the way that you do this in your calculator, and this was an easy one to do 7 times 6 times 5, but some of these will be a little bit more difficult. So if I do this in my calculator, I have 7. I go to math, the last column, and notice in the last column we have NPR. So if I go to number 2 and hit enter, and then, oopsies, I had to put in 3. So NPR choose 3. Gives me 210. So 2 different ways of doing the same problem. Doesn't really matter which way you use. So if I look at number 2, it says how many 4-letter codes can be made from A to Z if no letter can be used twice, so no repeats. In this case, if we want a 4-letter code, that means we have 4 spaces. Then you have to think, well, A to Z, how many letters are from A to Z? 26. So 26 letters in the alphabet. So for the first spot, you would have 26 different letters to choose from. Since we can't repeat, then the next one would have to be 25, and then 24, and then 23. So this right here is going to give us our answer. Or we could do, in our calculator, instead of doing 26 times 25 times 24 times 23, we have 26 P4, which will also give us the same answer. So if I do that real quickly, 26, math, go to the last column, number 2, enter, oops, I forgot to enter the number again, and 4, 26, choose 4. So I'm going to write this down, 358,800 different codes. The next one says 12 students enter a race, but there are only 3 top winners. So for this one, we're doing 12P3. So 12 times 11 times 10 would give me my answer. And if you do this in your calculator, you end up with 1,320 would be your answer. So that's how many different ways we can have, how many different possible permutations there are for people who can win the race. Now, the next one says we're going to talk about combinations. So a combination is a selection of objects when order does not matter. So that is the key right here. So order does not matter for a combination. So make sure you remember that. So again, in a permutation, order is important. In a combination, order does not matter. Now, the formula that we are going to use is in our calculator, NCR, where N stands for the number, again, the total that you have, and R stands for how many you're choosing. And so the actual formula is n factorial over r factorial times n minus r factorial. We're not going to really use that because we're just going to do it in our calculator. Note that combinations are smaller than permutations. So why are combinations smaller than permutations? Let's think about that for a minute. And I'm going to write combinations over here. So let's say we have the numbers 1, 2, 3. Now, if I have the numbers 1, 2, and 3, and I want to figure out how many different permutations I can have, remember that for permutations, ordered matters. So 1, 2, 3 is not the same as 3, 2, 1, nor is it the same as 2, 3, 1, and so on. So for permutations, I have 3p3. So when I do 3p3, I end up with 6. So I should be able to, when I do these combinations here, come up with 6 total possibilities. And of course we could do that, but I'm going to save some time and go to the combinations. So now for combinations, if order does not matter, then if I have the numbers 1, 2, and 3, well, 1, 2, and 3 would be no different if order doesn't matter than 3, 2, 1, or 2, 1, 3, etc. So they would all end up being the same. So if order does not matter, then I have only one possible choice that I can have. So because it would be 3C3, because you have 3 numbers and you're choosing 3. So if you do 3C3, 1 would be your solution, because if order doesn't matter, this would then be the same as this, and so on and so forth. And that's why usually combinations are going to be smaller than your permutations. So let's do some more practice. So if we're going to evaluate these expressions, 10C5. So if we go to our calculator, we're just going to do this on our own. So we have 10. You go to math for probability, go over here, and notice number 3 gives us our C, which is combinations. Oops. And then after you do that, you want to enter in how many you're choosing. So we said, I think 5. So 10 choose 5 would be 252. So you guys do B and C. Number 2 says, a reading list for a course in world literature has 20 books on it. And how many ways can you choose 6 books to read? So notice that when we're doing these problems, we have to decide if it's going to be a permutation versus a combination. Usually the word choose is going to help us determine if it's going to be order mattering or not. In this case, if you're reading, if you have 20 books to choose from and you're choosing 6 of them, it doesn't say anything about the order which you have to read the books. Since it doesn't say anything about the order that we have to read the books, I know I'm doing a combination. So there's 20 books total, and we're doing a combination of, we're choosing 6 different ways. So if I do 20C6, I end up with 38,760 ways that you can choose the books. So ways to choose 6 books out of 20. For number 3, it says a disc jockey wants to select 5 songs from a new CD that contains 12 songs. How many possible 5-song selections are possible? So for this one, it doesn't say anything about mattering which order the songs go in. So again, this is a combination. So 12 choose 5 is what I'm going to be doing. So if you plug this into your calculator, 792 would be the possible 5-song selections. So then for the next one, it says, a pizza menu allows you to select 4 toppings at no extra charge from a list of possible 9 toppings. In how many ways can you select 4 or fewer toppings? Doesn't say anything about the order mattering, so we know we're still doing combination. And notice that it says 4 or fewer toppings. So this one's a little bit different because we have 9C4 because we could choose 4 toppings plus, well, now we have to add that to, what if we only do 3 toppings? So 9 choose 3. And we could do 2 toppings, so 9C2, plus we could do 1 topping, which would be 9C3. 9C1 plus we could have no toppings, 9C0. So this is what I'm going to have to do. I can do this all in my calculator, which is kind of nice. So I can just really type that in. So we have 9 math, go to probability number 3. So 9, and we're doing the combination of 4 plus 9 math probability number 3. So 9, and we're doing a combination then of 3 plus 9, oops, and we're doing a combination of 2 now plus 9 and now we're doing a combination of 1 plus 9 and we're doing a combination of none. And we end up with 256. So there's 256 ways to select 4 or fewer toppings. So why don't you guys see if you can do number 5, 6, and 7 on your own and bring that with you to class, and then we'll go over them together.